Okay, this is a component method for finding the resultant of two or more vectors. So this is the example I'm going to use. Vector A, 25 newtons at 60 degrees, 10 newtons at 180 degrees, and 16 newtons at 315 degrees. First thing we should do is draw a sketch. So I have a sketch here. Remember, 0 degrees is north, 90 degrees is east, 180 is south, and 270 is west. So A is going at 60 degrees, B is 180, and C is 315. Now we're going to do this step by step. First of all, dealing with vector A. Vector A is 60 degrees from north. Okay, and what we're going to do is we're going to break this vector A into components, x and y components. There's my a sub x, and there's my a sub y. The angle here we're going to need, and it can be readily apparent, that's 30 degrees. Okay, now to find component a sub x, which is the adjacent side in my vector triangle to the angle with a hypotenuse of 25, we're going to use a cosine function. So cosine of 30 is a sub x over 25. Multiplying the 25 over, we get a sub x is equal to 25 times cosine of 30, which turns out to be 21.7 newtons. Let me get that out of the way. Okay, now doing the same thing for a sub y, which is the opposite side, we're going to use a sine function. Sine of 30 is a sub y over 25. Multiply 25 over, and a sub y turns out to be 12.5 newtons. Okay, that's vector A. Now, and I put it in my diagram up there. Now let's deal with vector B. Vector B, notice, is completely vertical, right? So B has no horizontal component. We would say that B sub x is equal to 0. And we can say that B sub y is completely vertical, so it's 10 newtons. B sub y is 10 newtons. However, it's pointing down, so we need to assign a negative sign to it. So B sub y is negative 10 newtons. Again, it's negative. By inspection, we can see that it goes in the negative y direction. All right? Okay, so I put it in there. Now, let's deal with vector C. Vector C, we can break it into components, c sub x and c sub y. And the angle here is the difference between 315 and 270, which is 45. C sub x is the adjacent side to my angle. And so we're going to use a cosine function, which is the cosine of 45 is c sub x over 16, 16 being the length of vector C, the hypotenuse. Multiplying 16 across, and it turns out to have a value of 11.3 newtons. And I'm going to, again, assign a negative sign to it. It's negative since it points in the negative x direction. That's something you have to pay attention to, and just assign a negative sign to it. Your calculator will say positive 11.3, but you just put a negative sign on there if it points to the left. Okay? All right. To get c sub y, which is the opposite side, we're going to use the sine function. Sine of 45 is c sub y over the hypotenuse, 16. Multiply the 16 across, and it turns out to be 11.3, this time positive, because it's pointing in the positive y direction. Okay? All right, so now we have all of our components, x and y components for each of our individual vectors. And so now what we can do is add the x components together to find the x component of the resultant, and add the y components to find the y component of the resultant. So r sub x is going to be a sub x plus b sub x plus c sub x. Substituting in the numbers, it turns out to be positive 10.4 newtons. Same thing with the y components. Add them together, and we get, after inserting them, remember the negative, and it turns out to be 13.8 newtons, positive. Okay, so now we have our x component and our y component of the resultant. So now we can draw our vector triangle. Okay, there's my x component, there's my y component, add them tail to tip, and we can get our resultant vector from where we started to where we finished. Okay? Notice that it's a right triangle, so now we can use the Pythagorean theorem to find the magnitude and the tangent function to find the direction of this resultant. First, finding the magnitude, Magnitude of r squared is equal to one leg squared plus the other leg squared. And it turns out to have a magnitude of 17.3. To find the angle here at the origin, we can use the tangent function. Tangent equals opposite over adjacent, 13.8 over 10.4, which happens to be 1.33. And then taking the inverse tangent of 1.33, it's 53.0 degrees. Okay? Now, remember that north is 0 and east is 90. To find true bearing, we need to subtract this angle from 90, because I'm starting at 90 and going back towards 0. So we're going to subtract this 53 degrees from 90 to get 37 degrees. And then our final answer then is that R is 17.3 newtons at 37 degrees. Okay, and that's the component method of finding a resultant.